to transmit power on a continuous basis. Combining gears of different diameters affects rotation speed and force. This factory makes gears that go into transmissions for industrial machines. Production begins with a large round bar of high-grade steel, which contains a certain amount of carbon to make it even stronger. An automated bandsaw slices off a piece that's the right thickness for the size of gear they're making. This piece is called a gear blank. They mount the blank on a computer-controlled lathe. As it spins, a turret carrying a series of carbide tools moves in. One tool after another takes its turn machining the blank to a specific shape. A shower of coolant prevents overheating when the jumbo drill has its turn. It bores a hole right through the middle of the blank. The last tool carves a groove on the front of the blank. This final bit of metal removal lessens the gear's weight. Now the blank goes into a computer-controlled mill. The mill drills holes through which lubrication will flow when the gear is operating. These holes also lighten the gear's weight. When the blank comes off the mill, they stamp it with the company name and part number. Now for the gear's teeth. A machine called a gear shaper carves out the inner teeth, the ones lining the center hole, with its titanium-coated cutter. The machine's other components keep the cutter's movement correctly timed. The number of teeth and tooth size vary from gear to gear, so for each model, the factory has to fit the gear shaper with a specific cutter. Now for the outside gear teeth. The computer-controlled machine that cuts them is called a gear hopper. The gear turns against it as it cuts. If the hopper would cut the full depth of the teeth in one shot, the cutter would chip. So the gear keeps turning around and around again as the hopper cuts a bit more with each pass until the teeth are the right depth. Then the gear undergoes a computerized inspection. A probe scans the entire surface, including every tooth. It sends data to a computer which then analyzes the dimensions and ensures they meet the engineering specifications. Gears that pass this quality control inspection go into a furnace for heat treatment. This strengthens the steel. When the furnace reaches a certain temperature, they inject carbon inside. The gears absorb it, and the steel strengthens even further. A soaking in oil afterward hardens the metal. Heat treatment, however, distorts steel somewhat, so each gear now goes to a computer-controlled grinder. It restores them to very precise specifications for bearings to fit properly. This factory manufactures gears in various sizes, and not only in steel. It also makes gears in materials such as nylon, aluminum, brass, and stainless steel. Some gears have straight teeth, others angled teeth, which makes less noise when turning. Gears are an essential component in everything from watches to heavy mining equipment, keeping machinery going at every turn.